Hi and welcome to our video. My name is Craig Williams and I am the UPS Training Manager for Ametek Solidstate Controls here at our fantastic state-of-the-art facility for training in Houston, Texas. And today we're going to walk you through how to power down a DPP UPS that has a remote manual bypass switch attached. This allows all power from the UPS to be completely removed and therefore allow you to work on this safely. But please remember, this procedure only applies to systems that have an external remote manual bypass switch. It does not apply to systems that only have a bypass switch mounted onto the UPS itself. In those circumstances, that bypass switch will always have bypass supply going to the terminals, and therefore the whole unit will not be volt free. So this does not apply to those systems. So what I'll do is walk you through exactly what the UPS should look like in normal operation. Obviously, all of the breakers on the front of the UPS should be closed, and we should have the UPS normal green LED light on, and we should have the green in sync light on. If we look at the mimic screen here, there is a bold line that shows you the power flow. And the power flow goes from the input to the charger, and it says charger OK here. Then it goes into the inverter. It says inverter OK. And then the power goes all the way through to our inverter static switch, which is this block here, and then out to our load circuits. And you can see that the battery line is also in bold, and the battery input breaker is closed. The float LED should be on green, and the inverter to load LED should be on green. So that is what your system should look like in normal operation. Now bear in mind that your UPS may have different options, and you may not have as many LEDs on the front of your UPS, or you may have the same amount of LEDs, but some of your alarms will be different from the ones that we have on this UPS. Also, you may have additional breakers. You may have a inverter output breaker on your system. But when we go through the procedure, it's still the same procedures that we use, but sometimes there will be an additional step on your placard that you will have to follow. The most important thing I could always say is make sure you follow the procedure on the placard on the front of your UPS. The principles are still the same. Sometimes you will have an additional step in your procedure. Okay, so we're going to walk through the shutdown procedure. The first thing that it says is press bypass to load, push button. Okay, and our UPSs, our DPP UPSs especially, are very clever. The system is always looking at the bypass supply, making sure that its voltage, frequency, and phase relationship to the inverter output are pretty much identical. Everything has to be approximately the same. If there is something wrong between that relationship, then it will not allow a transfer to bypass if you press that button to protect the load circuits. So it's kind of a fail-safe operation, so you cannot jeopardize your load. So when I press this button, it does a self-check, and if everything is okay, it will transfer to static bypass. So there we are there. Now if you did this at a UPS at your plant, more than likely the buzzer would be going off at this time. Due to this being in a lab, and we switch this UPS on a very frequent basis, we've disabled the buzzer on this alarm because it would make too much noise and it would ruin this video. But if you need to get rid of the alarm, you just press alarm silence, and that will turn the alarm off. And that will have to be pressed multiple times during this procedure, because the alarm will come on for each individual alarm that comes on throughout this procedure. And as you can see, the amber light has come on for the bypass to load, and you can see we've now moved from UPS normal operation. We now have a UPS trouble alarm, and the mimic screen has gone directly to the alarm status screen, and it says bypass supplying load. That's the alarm that we have on just now. So the bypass supply is now feeding the load circuits through the static switch internal to the UPS itself. So I will press the mimic key, and you can see that the bold line has now changed to the bypass supply. You can see the bold line is now going through to our bypass static switch, which is now closed, and below that you can see that the inverter static switch is open. That is normal after we have pressed the bypass to load push button. The next line of the procedure says transfer remote manual bypass switch to the bypass to load position. So you would have to go over to your remote manual bypass switch. Now remember, this could be anywhere in your UPS room. It probably isn't going to be right next to your UPS. It might be, but 9 times out of 10, it's always on a wall where there was space, and it might not be right next to your UPS. But this is what it should look like. And we're in normal operation just now, and the procedure asks us to move to the bypass to load position. You can see we have a warning label here that says do not transfer to or from normal operation unless the unit is in sync. And you can see there's an LED on the bypass switch that says in sync. And the thing that I like to tell all of my clients that come to our training classes is make sure this amber light on the bypass to load push button is on before you move from normal operation to bypass to load, or from bypass to load to normal operation. Okay, so I'm going to move it from normal operation to bypass to load because we have in sync and we have the amber light on. So at this point here, the bypass is now feeding power to the load circuits through the manual bypass switch. The power is coming from your MCC, it then goes to the contacts in the switch, and then directly back out to your load circuits. At no point now is any current flowing through this UPS circuit to your load. All of the load is being powered from your RMBS switch. Okay. The next line of the procedure says turn off the inverter by transferring the inverter enable switch to the off position. This is the inverter enable switch we are in on just now, and if you listen you can hear a high pitched noise. That's telling us that the inverter is running. Our frequency of our PWM is about 8 kilohertz, and that's the noise that you can hear. So when I switch this to the off position, that noise will stop, as you heard there, and then also we've gone back to the alarm status screen because we have 2 extra alarms. It now says inverter low voltage fast and inverter failure. Obviously we turn the inverter off, so there is no output voltage, which is why we get the voltage alarm, and the inverter failure alarm is telling us the inverter has failed, and obviously that's correct because we turned it off. So you will now press the mimic screen, and in the box it will say inverter fail because the inverter is off. The next line of the procedure says open AC input breaker. So here is the AC input breaker here, and I'm going to turn it to the off position. Once again, the UPS takes you automatically to the alarm status screen, and we now have a charger failure. And that's correct because the AC input supplies 480 volts to the charger circuit. So when we remove that 480 volts, the charger has no power to work, so the charger is now off. And as you can see in the box here, it says charger fail, which is correct. The next line says open battery input breaker. So here is our battery input breaker here on the UPS, and I'm going to open it. Once again, the UPS is taking us directly to the alarm status screen, and we have some additional DC voltage level alarms. It says low DC voltage, low DC disconnect. We also have the battery breaker open alarm, and we have DC too low for start. These are all the correct alarms because our DC bus within the UPS has started to discharge through the capacitors and the resistors that are connected in parallel with those capacitors. And if I press the mimic button, you can now see that the DC bus inside the system is now below 30 volts DC from 135 volts and is still going down as I speak. So the capacitors are discharging, so they will be safe to work on after about a minute or 2. And the last line on this placard says open bypass input breaker. So here is the bypass input breaker here, and I'm going to open it. And this is the point that scares most people during the procedure. because the screen has now gone off and all the fans in the UPS have gone off. And that makes people panic and think that their load circuits have now lost all power. But that's not the case. We still have bypass supply coming in to the manual bypass switch here, going through these contacts on the switch and going out directly to your load circuits. Everything on your load circuits is still powered up and healthy. So at this point here, we still have battery voltage coming from the battery to behind this battery input breaker. We still have three-phase 480 volts coming from your MCC bucket to the back of this breaker, and we still have bypass input voltage coming from this bypass switch to the back of this bypass input breaker. We have to remove all three sources of power to be able to work on this system safely. So the first thing we need to do, and it's not mentioned on the procedure here, is we need to remove the bypass power to this breaker here. And the way that we do this is the third position that's on our remote manual bypass switch, and it's called isolated bypass. And all it does is remove the voltage from this switch to this breaker here. So if we go to the bypass to load position, from the bypass to load position to isolated bypass, we have now made this breaker volt free. Now what you would need to do is go to your MCC and find the three-phase 480 supply that supplies the AC input to the rectifier. And you would need to open the bucket and you would need to put a lockout tag out on that breaker. Then the last source of power is the battery. Hopefully your engineer who designed your UPS has installed a battery disconnect external to the UPS next to the battery. And in that case, you would go to that external battery disconnect, you would open it, lock it and tag it out, and that would remove the power from this breaker here. And what I forgot to mention on this switch here, we have a mechanism that you can lock and tag out this breaker. You push this red button up and it allows you to put a padlock or a hasp through the holes here, and that prevents the switch from being moved from the isolated bypass position to the bypass to load position. So that can act as a lockout tag out point also. Once you have removed all those sources of power and they are locked out and tagged out, everything within this UPS is now completely volt free, apart from any alarm contacts that you have from your DCS system. So you would need to isolate any DCS power to your alarm contacts inside this UPS, and then is completely safe to work on. You can remove capacitors, replace parts, clean it out and do maintenance if necessary. The really good thing about a remote manual bypass switch is when you are in this position, say this UPS was now 20-25 years old and you wanted to replace it with a new UPS. At this point here, you could remove the wires from this UPS, from the terminals on the back of this panel here completely, and you could actually pull this UPS out, get a new UPS, put it in its place, make the connections back again, and then follow the startup procedure, and then you would have been able to completely replace this UPS while keeping your load circuits powered up without having to drop your load. So it's a really, really good point of having a remote manual bypass switch. It gives you so much versatility when it comes to maintenance and when you need to replace your UPS eventually. So that is how to get your DPP from normal operation to completely volt free and still keeping the load circuits powered up. I hope you enjoyed this video. Look out for more coming soon on our YouTube channel. Thank you for watching, and I'll see you next time.